What's up, guys? Here are 5-7 notes. Okay, we're talking roots and zeros. So if you have any x to the n power, it's going to be a polynomial with a degree of n. We're expecting to have n roots, counting double roots. Okay. So if this was x to the 5th, we'd be expected to have 5 roots, 5 zeros. X to the 7th, we're expecting to find 7 roots, or 7 zeros. X to the 10th, we're expecting to find 10 roots, or zeros. Okay, here we have f of x equals x plus 1. This is x to the 1st plus 1. X to the 1st, first degree, we're looking for 1 root. And if you graph this line, sure enough, it crosses the x-axis one time at -1. That's our root. Okay, if we did this one, x squared plus x minus 2. Biggest one there is x squared. We're expecting 2 roots. If we factor and solve, our roots should be -2 and 1. If you were to graph this out, alright, we're going to be looking at something like this. Okay, it crosses twice, -2 and 1. X squared plus 10x plus 25. That would factor out to x plus 5, x plus 5. Both of those are -5. This is a double root. Double root. Okay, think about what this is. It's going to cross at or touch at -5. It's going to look like this. It's not going to cross through. Okay, it's going to touch and turn around. Sorry. It's going to touch and turn around at -5. That's a double root, and that's why. Okay, it happens twice. Okay, x to the 3rd, we're expecting 3. X to the 3rd plus 25x. Use our factoring techniques. What's in common? Pull out an x. What would make each thing equal 0? Well, if 0 would make that one equal 0, what would make this equal 0? If x squared was -25. Oh, I don't know if x squared can be -25. Well, we did that this year. Okay, square roots of negatives. We're going to get plus or minus 5i, 2 imaginary roots, a positive 5i and a negative 5i. What will this look like? Now this isn't exact, but it's going to look something like this. We're coming up and we're crossing through 0. Okay, and we're going to have a little squiggle and back up. It's going to look something like that, maybe more like this. Okay. We're coming up, we go through 0, little squiggle, and back up. Okay? It's x to the 3rd, we're expecting it to cross 3 times. It only crosses once. So where do the other 2 come from? Imaginary roots. Okay? Slight change this year in the presentation. Okay, so this rule is just going to be like an information-only kind of thing. I'm still going to run through it pretty solidly in case we change our minds next year and come back to it and use it a little more. But for this year, January, February 2020, we are just going to have an awareness level of this property. So Descartes' rule of signs. Okay? The number of positive real zeros in a function is equal to the number of sign changes in f of x, or less than that, or smaller than that, by an even number. Why less than that by an even number? Because imaginary numbers happen in pairs, always a plus minus. Okay? So that's why they would always decrease by 2s, or even numbers. Negative real zeros is equal to the number of sign changes in f of negative x. Okay, and that gets tricky if you overthink it. Okay, and I'm going to show you a way to do it where you don't overthink it and why that works. You just have to go with that. If you try to overthink it, you're going to make life a lot difficult or more difficult for you. Excuse me. So we're looking at f of x equals 2x to the 5th plus x to the 4th plus 3x to the 3rd minus 4x squared minus x plus 9. So this is our regular f of x. We're trying to count our sign changes. Positive to positive didn't change. Positive to positive didn't change. Positive to a negative, there's one change. Negative to a negative didn't change. Negative to a positive, two changes. Two sign changes, so I would expect two positive real zeros or none. Okay, count down by twos. Two or none. Okay, f of negative x to find our negative roots. Okay, here's the tricky part. There's a lot of negatives with all these exponents, like, what's going on? Okay, think about this. Negative x squared. What's negative 5 squared? Negative 5 times negative 5. Negative times a negative is going to be a positive 25. Okay, so if you had a negative to an even power, the negative doesn't really come into play. But with the odd powers, okay, let's think of one here, like 2. 2 to the third. 2 times 2 is 4 times 2 is 8. Negative 2 to the third. Negative 2 times negative 2. Positive 4 times negative 2 the third time flips it back to negative 8. Okay, so if we can kind of carry those forward, that the fourth is going to be kind of like the squared, and the fifth is going to be kind of like the third. So all the even powers, 2, 4, 6, the negative is not going to affect it. Okay, it's going to end up being negative times a negative and come back to a positive. Whereas the odds, that's where it's going to flip it. So the shortcut is just flip the signs on all the odds. Okay, all the odd exponents. So I'm going to change this one to a negative 2x to the fifth. That one's an even power, it stays the same. Flip this to a negative. That one stays the same. Flip this to a negative, flip it to a positive. And that one stays the same. Now let's count our sign changes. 1, negative to a positive, 1. Positive to a negative, 2. Negative to a negative, negative to a positive, 3. Positive to a positive. 3 sign changes, so 3 or 1 negative real roots. Okay, we don't go below 1, can't have negative roots. Okay, so we have 3 or 1. Alright, so it was an x to the fifth. We're expecting 5 total roots. Descartes' rule of sign changes told me to expect 2 or 0 positives, 3 or 1 negatives. Okay, so if it was 2 and 3, that'd be 5 already. There wouldn't be any imaginaries. If it was 2 and 1, that's a total of 3. Or 0 and 3, that's a total of 3. I would still need 2 roots to get to my 5, so then there must have been 2 imaginaries. Or the other possibility is 0 and 1, and then I would need 4 imaginary roots. Okay, so that is just kind of an awareness level. Last year, or previous years, they had to do all that and come up with all of this before actually solving. So we're going to keep this in this video, just in case I change back. But you guys just have to have an awareness level of this, and you're going to be more like this. Okay, here's what's going on. Find all zeros. Okay, for x to the fourth, no x to the thirds, minus 18x squared, plus 12x, plus 80. Alright, so in case this video gets reused for a later year, let's count those sign changes. Positive to a negative, there's 1. Negative to a positive, 2. Positive to a positive. So we had 2 changes, so we had 2 or 0 positive real roots. F of negative x, we're going to change our negative powers. X to the fourth was even, it doesn't change. X squared is even, it doesn't change. X to the first, that's odd, change it, and that one stays. Positive to a negative, negative to a negative, so we only have 1 change, back to positive, 2 changes. 2 or 0 negative real roots. Alright, this is an x to the fourth for the highest degree here, so I'm expecting 4. So if it goes 2, 2, we're going to have 0 imaginaries. If it goes 2, 0 or 0, 2, we would need 2 imaginaries, or if it goes 0, 0, we would even need 4 imaginaries. Okay, well, let's find out. It's the year 2020, we got these fancy graphing calculators. Let's find out. Okay, cover up that negative x1. We're going to graph the original. So this is what you guys need to do. Graph the original. X to the fourth minus 18x squared plus 12x plus 80. Graph. I think this is a crazy graph. It's pretty steep. Yep. Pretty steep. Boom, boom. Okay, but let's take a look. We cross how many times? I only see two. We only cross twice. Where do we cross at? We got two negative answers. Looks like we're crossing at -2 and -4. So I had the two negative ones I predicted. I don't see any positives. So 0 positive real roots, 2 negative real roots. That must mean it's 2 imaginary. Okay, so we got to solve them. We got to find them. How do we find them? We reviewed synthetic division just for this. Okay, make a note of where it looks like they cross. It looks like they cross at -2 and -4. So we're going to use some synthetic division. Let's start with the -2. Alright, also a little sneaky right here. No x to the thirds. Make sure we put our placeholder in. So we got 1x to the fourth, 0x to the thirds, -18x squared, 12x plus 80. Okay, synthetic division. 1 comes down, multiply it up, put it underneath, -2. Add down, -2, times -2, +4. Add down, -14, times -2, +28. Add down, 40. 40 times -2, -80. No remainder. So that means that this is a root. It is a root. Okay, it goes in perfectly. Okay, so that's a root. This would now be 1x to the third minus 2x squared minus 14x plus 40. There was another one, right? There was a -4. Okay, so I'm not going to go back up to the top. I'm going to keep going down. I'm going to use these numbers now. Because if I use these numbers, I was at x to the fourth. Now this is 1x to the third. If I do it one more time, I'll be down to x squared. And once I get to x squared, I got all kinds of tricks I can use to find zeros, roots, factors, that kind of stuff. Okay, so if you're worried that your eyes are going to play tricks on you, you can rewrite those numbers like right here and then go from it. Otherwise, if you want and you think you can handle it and not like lose track of stuff, you can put this -4 right here and just go down from there. So the 1 goes down, -4. Where'd that -4 come from? Okay, remember that was our other one. On our graph here, it looked like it crossed at -2. Okay, it worked out to be that because it didn't have any remainder. And it also looked like it crossed at -4, so that's the other number we're going to try. Okay, -4 adds down to -6. Negative times a negative, we got a +24. Adds down to a +10. -40. Don't use this number. Okay, no remainder. Bingo. Okay, so both of those worked. Those are my 2 zeros. Okay, 2 zeros. It says find all zeros. Alright, so I'm down to some x squared. This is 1x squared minus 6x plus 10. Okay, we're down to the x squared level. We got all kinds of tricks. There's no number in front. This should be pretty easy to do the magic x. Is there anything that multiplies to 10 and adds to -6? And the answer there is no, there is not. Okay, think about this. We said there's 4 roots. I'm only seeing 2 of the negatives, just like we predicted here. Okay, where would the other 2 come from? Imaginaries. So if it's imaginary, it's not going to factor. So if it doesn't factor, what do we have to do? Quadratic formula. Okay, quad formula. Well, let's see if I can reach around the computer here. Okay, our quad formula, we got -b plus minus square root b squared minus 4ac all divided by 2a. I'm using capital letters because you know how bad my little lowercase letters look. They're easily confused with some numbers. Alright, so let's drop these in. There's a, there's b, there's c. a, b, c. 1, negative 6, 10. So negative 6 for b. So negative of a negative 6. Negative 6 squared. 4 times 1 times 10. 2 times 1. Alright, negative of a negative is going to be a positive 6. Plus minus. What do we got going on under there? Negative 6 squared is 36. Positive 36. 4 times 1 times 10, that's 40. Negative 36 minus 40, negative 4, because that's where we're getting our imaginary from. Negative 4. Okay, so over 2, we're going to do that square root. We can do that. Negative 4, that's going to be 2i. What do you notice about these? 6, 2, 2. They're all even. So this is going to reduce by a factor of 2. 3 plus or minus, not 2, 1i. And you don't need the 1. You could write it as 3 plus or minus I. Okay, so we were expecting 4 roots. Negative 2 and negative 4. We've got the initial idea for those numbers from the graph. We double-checked them in synthetic division. They worked. We got all the way down to this. We went from x to the 4th, x to the 3rd. Now we're down to x squared level. We tried to do our factoring techniques. It didn't work. Quadratic formula, that's where we got our imaginaries. Negative 2, negative 4, 3 plus I, 3 minus I. So there's your 4 total roots. One last problem to look at. I don't have any particular examples for you to do. We're going to talk about one. Complex conjugate theorem. We kind of looked at this already. Imaginary roots come in pairs. So if 3 plus 4i is a root, then the opposite one, 3 minus 4i is a root. It comes in plus minus pairs. Okay, so one of the types of problems is going to be write a polynomial function with these zeros. 2 and 5 minus I. Well, if we have a 5 minus I, we're also going to have a 5 plus I. So if 2 is a root, okay, it's going to be x minus 2. Okay, x minus 5i, that's going to get a little tricky. X minus 5 plus I. So then you could distribute your negatives and multiply that out. Okay, or you could maybe leave it in factored form. Alright, just be aware of that, that if they give you a 5 plus I, it's going to be a 5 minus I. There's going to be a partner with it. Okay, there you go, folks. Now you are prepared for 5-7. Best of luck.